Let's take a look at a similar triangle problem. What we have is two triangles. The one on the left has all of the dimensions given, and the one on the right has two missing. Now the key is these are similar triangles, or it means they are in proportion. Kind of like blowing up a picture. When you blow a picture or a photograph up, you blow it up in proportion, so you stretch it the same way lengthwise as you do heighthwise. And that's the same idea here. We're going to stretch all of our dimensions by the same proportion to keep things equivalent. So to decide the missing measurements, we want to pick one to focus on first. We'll do the red or the bottom measurement. And what we're going to do is set up a proportion between corresponding measurements. If you notice, the size 18 is given in the larger triangle. And that corresponds to the side of 12 in the smaller triangle. They're the same up-down measurement, the vertical measurement. I'm not sure of the bottom measurement in the large triangle, so I'll call that x. But the bottom measurement in the small triangle is 16. You notice I have the vertical for the large triangle, vertical for the small triangle, horizontal for the large, horizontal for the small. So they're all corresponding measurements. The next thing I'll do is go ahead and solve this proportion by cross multiplying. 18 times 16 is 288. And cross multiplying the other way, 12 times x is 12x. We'll finish out by dividing 288 by 12 to find that the missing side of the triangle is 24. So to keep things in proportion, this bottom side of the triangle must be 24 units long. Next, we'll go ahead and solve the purple side in a similar manner. I know and I was given that the vertical side is 18 of the large triangle and the vertical side of the small triangle is 12. Those are what we call corresponding sides. They're in the same position. I'm not sure of what we call the hypotenuse or the slanty side of this large triangle. We'll call that x. But the hypotenuse or slant on the other triangle is labeled 25. So we know that measurement. Again, same method for solving this. We'll do 18 times 25 to cross multiply this way. And cross multiplying the other way will give us 12x. And then we'll go ahead and divide both sides by 12 to give us 37.5. So this side of the triangle would be 37.5 units. And you've just completed all sides of the similar triangles.